Next up, we've got a couple of ships sailing in the ocean. I'm assuming in the ocean. At noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers an hour, and ship B is sailing north at 25 kilometers per hour. We want to know how fast the distance is changing between the two ships at 4 o'clock p.m. I want you to take a minute to see if you can draw a picture of this situation and identify the distance it is, the distance between the ships that we're talking about. Come back when we're done, or when you're done. I'm going to go ahead and develop this with you. So at noon, we have ship A that is 150 kilometers west of ship B. And then ship A is sailing east, so toward where ship B was at noon. But at the same time, we have ship B, which is sailing north. The distance that we're talking about is the distance between the ships after noon, right? After some time has passed. We might be tempted to think it's this 150 kilometers, but as A moves and as B moves, that's not the distance between the ships anymore. What we're actually after is the distance between the tips of the arrows, essentially. That's the distance that's changing. I'm going to call that D. And then I'm going to call the distance that B has moved, well, B. And I'll call the distance that A has moved, A. Now you can kind of see the makings of a triangle here. It's a right triangle, and we are going to use the Pythagorean theorem, of course, because we're looking at D as the hypotenuse. I need a label, though, for this side of the triangle. And of course, if this is 150 kilometers, and this part I'm calling A, then the distance between where A is at a time after noon and where B was at noon is going to be 150 minus A. Let me fix that. There. Now, using these labels, we can say that D squared is equal to 150 minus A, the quantity squared, plus B squared. All we've done so far is we've interpreted basically the first sentence, or I guess the first couple of sentences, and then we have identified a distance. But now we need to bring in the calculus. How fast is the distance changing? And that means that we want, in terms of calculus, dt. So I have a d squared here, and I know that if I differentiate with respect to time, then I'll end up with dt. Note that we also have some other information also in terms of, well, it's not in terms of calculus, but we can interpret it that way. Ship A is sailing east at 35 kilometers per hour, so I can say dA dt is equal to 35. Likewise, ship B is moving at 25 kilometers per hour, and so dB dt is equal to 25. Folks, as you work through the exercises associated with these videos, like that are in the textbook, when you see like kilometers per hour or any rate here, I want you to think like, does that mean it's a derivative? Because it probably is. As before, we're going to differentiate with respect to t. So I've got 2d dd dt. That's basically implicit differentiation. The chain rule is coming out. Is equal to 2 times 150 minus a times negative dA dt. The derivative of the inside function does come with a negative. Plus 2b dB dt. I see that all the 2's are going to divide out, and that's cool. Now notice we said we wanted dd dt. Here's dd dt, so I can solve for that by dividing both sides by d. So dd dt is equal to 150 minus a times negative dA dt plus b times dB dt divided by d. After I've taken the derivative, and folks, for this entire series of videos and all the homework related to it, you're going to take a derivative and then you're going to substitute numbers in. You never substitute the numbers before you take a derivative, because then if I have like distance is equal to 12 or something, when I take a derivative, all derivatives are 0. You'll just find out that that doesn't work at all. At noon, the ships were in this position. I didn't mean to start that sentence. At 4 o'clock, it's been 4 hours since noon. So here, we're looking at t is equal to 4 hours. After 4 hours, so I'll say b of 4. After 4 hours, b has gone 100 kilometers. After 4 hours, a, so I'll call that a of 4, a has gone 140 kilometers. I'm going to take this triangle and redraw it over here. I have one side that's 100 kilometers and another side that is 150 minus 140 kilometers, so 10. That means that d is equal to the square root of 10 squared plus 100 squared. Now I have numbers to put everywhere in this expression for dd dt. dd dt is equal to 10 for 150 minus a times negative 35 for negative dA dt plus 100 for b times 25 for dB dt divided by the square root of 10 squared plus 100 squared. And let's put that into a calculator. And I get about 21.4. Now we see that everything was in kilometers per hour, and so at 4 o'clock, the distance between the ships is increasing at 21.4 kilometers per hour.